for the day is integrating transcendental functions. So when we say transcendental function, those function that contains a logarithm, natural logarithm, and exponential function. So our learning objectives, at the end of the lesson, the student must be able to define natural, logarithmic, and exponential function. Second is to derive exponential and logarithmic function. So the student must be prepared, pay attention, and participate. The definition of natural logarithmic function is defined by ln x is equals to the integration of x to 1 over t dt, where x is greater than 0. And then the definition of natural exponential function is the inverse of the natural logarithmic function, wherein it is defined by exponential of x is equals to y if f of x is equals to ln y. So this is the integration rule for integrating transcendental function. So if we have the integration of 1 over u du, then it is equals to the natural logarithm of u plus c. And if we have the integration of e raised to u du, then it is equals to a raised to u plus c. So this integration rule is used when we solve a problem later. But this is the basic integration formulas that we could found in our module. So just memorize the integration rule for transcendental function, and since it is found on our module, I assume that you already familiarized with this rule.
So let's solve this problem. The integration of 5a raised to 4y dy. So in this case, we know that the rule that could be applicable in this type of function is the exponential function, since we have e, which represent exponential, and the raised u and du. The general form of the exponential function is the integration of e raised to u du is equals to e raised to u plus the constant c. So now, in this case, we have a constant 5. So we can move 5 outside the equation, and we can write the equation 5 integration of e raised to 4y dy. But before we could apply the rule, we should identify first the u and the du. The u and the du. So our u, since the general form of the exponential function is integration of e raised to u du is equals to a raised to u plus c, this is our a raised to u. Therefore, our u is equals to 4y. And then, since it is our u, we could know that, or we could find the derivative of our u. So the derivative of u is equals to 4 dy. And then we have the nf is equals to 1/4. So now we can apply the rule. 5 integration of e raised to 4y dy. We should rewrite it. 5 integration of a raised to 4y dy. So our u is 4y and our du is equals to 4. Since we have the nf 1/4, and our dy is 4, we could multiply the reciprocal of 4, which is our nf, outside of the equation. So 1/4. Since 1/4 times 4 is equals to 1, then 1/4 times 5 is equals to 5 over 4. And then our e raised to u for y plus our constant c. So now this is our answer in integrating 5/8 raised to 4y dy. So let's try to solve the second problem, the integration of 10 over 2x minus 5 dx. So in this case, we know that the rule that could be applicable in this type of function is the natural logarithm, which is the integration of du over u is equals to the natural logarithm of u plus the constant c. So first, we need to identify our u and du. Our u and du. So our u in the general form is in the denominator. So our u is equals to 2x minus 5. And our derivative of u is equals to 2 dx. And we have the nf is equals to 1/2, which is the reciprocal of 2. That is why our nf is 1/2. So now we could apply the rule in this function or in this equation. So since our du is on the numerator and our numerator there is 10, so we could move 10 outside the equation, and our dx now is our numerator. So we can write the equation 10 dx over our u, which is 2x minus 5. And then we could multiply it by the reciprocal of our du. dx is 2 times the reciprocal, which is our nf, 1/2. So 1/2 times 2 is equals to 1, and then 1/2 times 10 is equals to 10 over 2. The natural logarithm of u, the natural logarithm of u, this is our u, so 2x minus 5 plus our constant c. So we can simplify this equation. So 10 over 2 is equals to 5. The natural logarithm of u, 2x minus 5 plus c. So now this is our answer in integrating the 10 over 2x minus 5 dx.